Welcome. I'd like us to start by looking at the parent graph of the hyperbola. So we will look at y is equal to 1 over x. I drew it there, and I want us to use that diagram there to answer a few questions. Please take note that a hyperbola has an unknown variable in the denominator. In this particular case, x is in the denominator, and that makes that function there hyperbolic. If you draw the graph of y equals 1 over x, you will get that green graph that we have in quadrant 1 as well as in quadrant number 3. Remember, this is quadrant 1, this is quadrant 2, this is 3, and that is 4. So these are some of the properties that we have to learn straight away. Then the asymptote. The asymptote is the line that the graph will never touch. The graph gets very, very close to the line, but they do not touch at all. So in this case, the asymptotes will be the x-axis as well as the y-axis. We prefer to give those as equations. The x-axis, remember, is given by y is equal to 0. And the y-axis is given by x is equal to 0. The domain, remember, is made up of the values of x that will give us the corresponding values of y. In this particular case, the domain will be every value of x except 0. So x is not equal to 0. Again, if you look at this graph, it looks like our graph will assume all the other values of y except the value y is equal to 0. And so you can write your answer as y should be a real number such that y is not equal to 0. For the axis of symmetry, we have two axes of symmetry for the graph y is equal to 1 over x. I drew them earlier on. One of the graphs is the line y is equal to x. The other axis of symmetry is the line y is equal to negative x. I just want us to look at the graph of y equals negative 1 over x. You will notice the only difference between this one and the first one is that the quadrant where we find our graph will now be quadrant 2 and 4. The rest will be the same. The asymptotes will be the same. The domain will be the same. The range will be the same. And the axis of symmetry will also be the same. Another thing I need us to think about is the shape of the hyperbola. So depending on the value of a, you will get your hyperbola. If a is positive, then we expect to get our hyperbola in quadrant 1 and 3. But if a is negative, then the hyperbola will be drawn in quadrant 2 and in quadrant 4. The graph that I've drawn there represents the function y is equal to 2 divided by x minus 3 minus 1. I want us to look at some of the obvious things from here and maybe learn a thing or two. If you look at this graph, it's red in this case. First of all, the asymptotes. Those dotted lines there are the asymptotes. So there is a horizontal asymptote, which is given by y is equal to negative 1. That dotted line there is y equals negative 1. Then there is a vertical asymptote, and that one is given there by the equation x is equal to 3. And now, where do you think, or how do you think these asymptotes can be determined from the equation that is given there? For the vertical asymptote, which is x is equal to 3, we definitely use the denominator there. That denominator there is x minus 3. And so if you want to know the vertical asymptote, you take your denominator, all of it as it is, and put it equal to 0, this will give you x is equal to 3. And the horizontal asymptote y is equal to -1 is coming from that q value there. Now, what about the domain of this function? Once again, if you look at the graph, this graph exists everywhere except where x is equal to 3 and except where y is equal to -1. And so to answer the domain, we just need x to be a real number, but x must not be equal to 3. And now for the range, you will notice again the graph exists everywhere except when y is equal to -1. So the range is all real values of y except -1. Then the axis of symmetry, I've drawn them there. Those are the blue lines. You will need to go back to the parent graph and remember that one asymptote from the parent graph is given by y is equal to x. But for this particular graph, there are some transformations that took place. X minus 3 down here tells us that this graph, or the parent graph, was shifted 3 units to the right. And the -1 tells us that it was also shifted 1 unit vertically downwards. So there are certain transformations that took place. So when the parent graph was shifting 3 units to the right and 1 unit down, obviously the original axis of symmetry y equal to x was transformed accordingly. So y equal to x must also be shifted 3 units to the right. And that means we have a -3 because it's a -3 that will define a shift to the right. But that is not all that happened. It was then shifted 1 unit down, which is a -1, which is that one there. If you simplify this, you will get x minus 4. Then to determine the other axis of symmetry, remember originally from the parent graph, the axis of symmetry, one of them was y equals -x. The graph was shifted 3 units to the right. That is why we have a -3. And it was shifted 1 unit down. And so when that happened, y equal to -x was also transformed the same way. So now we are saying instead of x, it should be x minus 3. Then it was shifted 1 unit down, which means -1. So this becomes the equation of that other axis of symmetry there. If they give you a question like this to sketch, you can make use of the properties. First of all, it should be the shape. So think about the shape. The second thing is the asymptotes. The vertical asymptote is found using the denominator. So the vertical asymptote is x is equal to 2. What about the horizontal asymptote? The horizontal asymptote is always given by y is equal to q. In this case, y is equal to 3. To get the y-intercept, I should put x equal to 0. So my graph will pass through the point 0, 0. For the x-intercept, we put y is equal to 0. All right, so our x-intercept is 0, 0, and our y-intercept is also 0, 0. All I do now is to draw the x and the y-axis. And the first thing to draw should be the asymptotes. Draw that, and label the equation, we need to know that that is x is equal to 2. So these asymptotes meet somewhere, they meet here, and they actually define 4 quadrants. Our graph should lie in quadrant 1 as well as in quadrant 3. You also get questions like this. They draw the graph for you and then ask you to work out the equation. Now this is clearly a hyperbola. You can tell that the a value will be positive because this hyperbola is drawn in quadrant 1 and in quadrant 3. So you know this will be, you know that a will be positive. Then the other values, like the value of p and the value of q, can be found from the equation. Remember, the equation will look like this. And we need to make use of the asymptotes in order to determine the value of p and the value of q. There are 2 asymptotes here. The vertical asymptote is given by the equation x is equal to -1. And the horizontal asymptote is this one here, which is y is equal to 2. All right. And so now we want to find the value of p. You will remember that to get the vertical asymptote, we need to take that denominator x minus p and make it equal to 0, which means we get x is equal to p. So our asymptote is actually x is equal to p from this theory. But if you look at the graph is telling us that the asymptote is actually x is equal to -1. So what does that tell us about p? That shows us that p is equal to -1. What about the value of q? Remember, the horizontal asymptote is given by y is equal to q. But from our diagram, we know that the horizontal asymptote is y is equal to 2. This then means the value of q is equal to 2. Now the only thing that is missing is a. And to get a, we need to sub in what we know. We know that 0.23, so we need to substitute that one in there. We also know p and we also know q. Then we can write our equation. Y is equal to 3 divided by x minus p, but p is -1, all that plus q, which is 2.